hopefully you maybe have up to like 12 squared memorized. We'll be using perfect squares in this chapter, and then in chapter 6 we'll be using perfect cubes, perfect fourths, perfect fifths, perfect sixths. So I'll have another worksheet that has like all the perfect powers on it. It's an easy reference to use, so you kind of know what numbers we're going to be working with. So after you have that complete, if you'll turn in your notes packet to section 4 and 5, which is page 23. So keep that on your desk, we'll kind of reference it. So again, page 23 in the chapter 4 packet, we're still in chapter 4. We're halfway through. There are 10 sections in chapter 4. We'll cover all of them, but section 4-9. So at the top of page 23, you see we're solving quadratic equations by finding square roots. And there are 3 radicals up here. Square roots is the same thing as a radical. I know that in geometry, with like solving for triangles, working through different problems, you've simplified square roots before. We're going to work on simplifying square roots today, but they're embedded in equations. So the common powers on that sheet is just a reference for you to use so that you have a visual, something to look at. Because when you're simplifying a square root, you need to use a power in order to break it down. So the first one, we have the square root of 100. And Julian, the square root of 100 is just 10, right? So that one breaks down nicely. It's just the number 10. Because it is a perfect square. But when you look at the square root of 200, on your sheet, you need to choose one of those numbers that is on the sheet you just completed that goes into 200. And we want the biggest perfect square, because that's how we work on breaking down perfect squares. So if you look at the square root of 200, our goal is to break it down, one number being a perfect square, the other number being what's left over. So what breaks down 200? What's one perfect square that goes into 200? The biggest perfect square that goes into 200. Ah?
13.
Say it again?
13
13
squared.
squared, so, but it needs to divide in evenly. So you need to find a number that's on your sheet that divides into 200 evenly. Julia?
10 squared.
So what is 10 squared? 100. So 100 times what, Julia, makes 200?
2.
Okay. So when we look at the number 200, we need to think what 2 numbers multiply to be 200. One of them has to be a perfect square. So 100 times 200 multiply to be 200. But we can take the square root of 100. So you're really looking at the numbers that you just wrote down. Because one of those numbers that you wrote down is a perfect square that would go into 200, and that would be 100. So it's 100 times 2. Julia, the square root of 100 becomes 10. So you keep the 10, and then the square root of 2, Julia, can you do anything with that besides getting a decimal value? No. So then we write the square root of 2 next to it. So simplifying a radical, you're going to use one of the numbers that you wrote down. Those are called perfect squares, the 100, the 81, the 64, 49. So we want one of those numbers to go into 200. That number changes because it is a perfect square, and then we have the square root of 2 left over. So this would be 10 and then the square root of 2. So looking at number 3, we have the square root of 75. So our goal is to break 75 up into 2 numbers. One of those values should be on the sheet. Okay, Matt, try again.
25.
Yeah, 25 and what, Matt?
3.
All right, so 25 and 3. So, Matt, 25 becomes 5 because the square root of 25 is 5, and then we keep the square root of 3. So the part that can't be broken down just kind of tags along after that number. So that's called simplifying a radical, simplifying a square root. Our goal is to get the number underneath the square root to be as small as possible. Questions? Alright, so there are a couple of words here. The first one we have is the word square root. Can anybody kind of describe what a square root is? Like, how would you describe a square root? What does a square root look like? Melanie?
Isn't it just a number multiplied by itself?
Yeah, that's perfect. So a number multiplied by itself. So 9 is 3 times 3. The number multiplied by itself. The square root of 9 is 3. So we could say 3 squared is equal to 9. That would be an example of a square root or a perfect square. So then there are two other words underneath. We have a radical and a radicand. So if I wrote the square root of r, the radical is the actual symbol. So the radical is the square root symbol. We'll see that as we work through the upcoming chapters, we won't just deal with square roots, but we'll deal with cube roots and fourth roots and fifth roots and sixth roots. So the square root is the one that you always see, but we're going to start seeing other values that are with this square root. The radicand is the number underneath the square root. So in this case, the r that I wrote here is the radicand. So the number under the square root. Or under the radical. So that actual symbol is called a radical. We just typically refer to it as a square root. So there are, I think, two properties underneath. One would be the multiplication property. The other one is the product versus the quotient property. And the product property is actually the one that we use to solve in those three warm-up problems. So the product property says that if you have two values underneath a square root, you can really separate those two values by just splitting them apart and taking the square root of the first number and the square root of the second number. That's the process we used for those first three problems. So if you look at the square root of 18, really there's just one number sitting there, but 18 can be broken up into two separate numbers. One of them is a perfect square. So yes, 3 times 6 makes 18, but 3 and 6 are not perfect squares. What would be a perfect square that makes 18? Matt? 9 and? The leftover piece is 2. So 9 times 2 is 18. 18 can be written as 3 and then square root of 2. So that's the product property. You can take a number and split it up into two separate values that are the product of that number, and then one of those two values can be reduced. The quotient property is pretty much the exact same thing, except we're dealing with quotient, which means we're dealing with division. So the square root of a divided by b can be split up into two separate square roots. So instead of having the fraction underneath, you can individually separate the fraction and look at the square root of a divided by the square root of b. So we have the square root of 2 25ths. Well, really, we could look at that as the square root of 2 and the square root of 25. Because then we can think about trying to break down one of those two numbers. So that's the goal of trying to use these properties so that it can help us break them down. So Maggie, this would become what?
The square root of
Yeah, the square root of 2 over 5. So the number you change is because it's a perfect square. So the radical part is gone because the square root of 25 is 5. So the radical is gone. Questions? So see if you can try and look at these 4 problems. Try and simplify them. First one is just the square root of 24, and then we have two numbers that are being multiplied together. Two radicals are being multiplied together. We have fraction in there. So the goal of that sheet that you have is, especially once the numbers get a little bigger, or maybe it's a number that you don't know the multiples for, you at least have some numbers to choose from when you're trying to think of the multiples of the value. So Emma, the two numbers that multiply to be 24, one of them being a perfect square, is 4 and 6, so the square root of 24 can be simplified to? Excellent. Letter B, we have the square root of 5 and the square root of 18. What do you think you're supposed to do with that? Odette? Yeah, so let's pull them together to see what number that makes. Odette, 5 times 18 is? 90. And then break that number down. So like we're multiplying them to pull them together, and then we'll try and break that number down. And Odette, the square root of 90 can be broken down into what two numbers? Good. Which becomes? Perfect. 3 square root of 10. So pull the numbers together first so that we are dealing with a bigger number, and then we can break that bigger number down. So letter C, we have the square root of 9/64, which really can be thought of the square root of 9 and the square root of 64. So, Graham, the square root of 9/64 is really?
3 divided by
Yeah. So both of those are perfect squares, it just becomes 3/8. And then D, we have the square root of 5 times the square root of 10. Garrett, what would that become? So the square root of 25 and the square root of 2, which reduces to?
5.
Questions? Okay, so if you look at the top of the next page, we're still going to work with square roots before we start breaking into some problems. So at the top of the page, there is something called rationalizing the denominator. So when we have a fraction, and I'll make it like this, and the denominator is not a perfect square. A fraction is really picky. You're not allowed to have a square root in the denominator of a fraction. It's considered unsimplified. So we use the process of rationalizing the denominator to get the square root out of the denominator. So rationalizing the denominator is taking the square root value out of the denominator. So if you look at the example I have up here, we have 3 over the square root of 2. How do you think you'd get the square root value out of the denominator? So we only want a nice whole number sitting there. We can't have a square root sitting in the denominator. It's considered unsimplified. How do you think we would try and get that out?
Did you multiply the whole thing by a certain number?
We do multiply the whole thing by a certain number. So that's what we're going to do. We're going to multiply this whole thing by a certain number, meaning the top and the bottom of the fraction. What do you think that certain number would be?
5?
What's in the denominator right now?
2.
Yeah, so we're going to multiply by whatever's in the denominator because that's the part we want to take out of the denominator. So if this was a square root of 2, and it is a square root of 2, we would multiply the bottom by the square root of 2 and the top by the square root of 2. You're allowed to multiply a fraction by anything as long as you do the same thing to the top and the bottom of the fraction. You're allowed to multiply an equation by anything as long as you do the same thing to the left and right of an equation. So it's keeping it equivalent as long as you're doing the same thing to the top and the bottom. So Abby, if you look at the top, we have 3 times the square root of 2, so that's going to stay the same. But what does the bottom become if we have the square root of 2 times the square root of 2?
Square root of 4.
And what is the square root of 4?
2.
Yeah. So by multiplying it by itself, we make it a perfect square number, and you can take the square root of that perfect square so that you no longer have a square root in the denominator. So it totally kind of changes the way the fraction looks, but the radical is no longer in the bottom of the fraction, and that's the goal of rationalizing the denominator. So if you look at the 2 problems here, it says rationalize the denominator, so we'll just practice 2 more of them to make sure everybody's okay with rationalizing the denominator. So the first thing, we have the square root of 5 and the square root of 2. I'm going to separate it. So here we have square root of 2 again. So we're going to rationalize the denominator, which means get the square root out of the denominator. It needs to be a whole number sitting there. So whatever radical or square root's in the denominator, that's what we're going to multiply by. And again, this is a square root of 2. So you have to do the same thing to both parts of the fraction. So Mackenzie Mallory, on the top we have the square root of 5 and the square root of 2. What does that become?
The square root of 10.
And then the bottom becomes,
Square root of 4.
which is?
2.
Right. So we have the square root of 10 and then divided by 2. So this is considered simplified because the square root is no longer in the denominator of the fraction. You cannot divide 10 by 2 because they're different types of numbers. The square root of 10 is a different value than the whole number of 2. So that's as far as that problem can go, but the goal is to get the square root out of the denominator, and that's what we do. So looking at letter B, we have the square root of 8 and the square root of 3. Julian, what will we multiply this one by? Right, so we want to get the radical out of the denominator. So Julian, the top becomes,
Square root of
and now the bottom is just 3. So the square root of 3 and the square root of 3 make the square root of 9, and that changes to 3. Julian, can the square root of 24 be simplified? Can that be broken up? What could we break that up into?
24. You could have the square root of 4 and the square root of 6.
There you go. So if the square root can be broken up, we still need to do that. So we can't just leave it at the square root of 24 because that can be simplified. So Julian, on the top of the fraction, it would be
Just 2 and the square root of 6.
perfect. So the square root of 4 becomes 2. We still have the square root of 6, and then on the bottom is 3. So that square root of 6 can't be broken down any further. 2/3, those two numbers are pulled outside of the radical. Those can't be broken down because 2/3 is as far as that can be broken down as well. Questions? It's rationalizing the denominator. Alright, so we're going to get to a couple equations finally because our problems are going to involve these square roots. That's why we kind of have to talk about them a little bit. So if you look at the first actual equations that we're solving here, you see that we're back to those those exponents of 2. So that's called a quadratic equation once you have an exponent of 2. And right now we have 1/4 times y minus 6 squared. So those two are right now in parentheses squared. And it's equal to 8. Kind of looks like vertex form a little bit here. We're going to try and solve this. How do you think you try and solve this problem? So try and think, if it's an equation, what is your goal of solving an equation? Any equation, what's the goal? Abby?
Find the variables.
Yeah, define the variables. So usually our goal is to get the x by itself. In this term, we want to get the squared term by itself. So we want to solve solve for the variable, well, we need to get that variable by itself because that's how you solve an equation. So we want to get the squared term by itself, or the y, or the x, whatever term it happens to be. So if you look in the front of the parentheses, there is a 1/4. How could we get rid of 1/4? Emma? Multiply both sides by 4. So we're going to take this 1/4 to the other side. That's usually the goal when you get something by itself. You want to take it to the other side of the equation. So 1/4 we can multiply by the reciprocal of 4. This is still y minus 6 squared. And Emma, 8 times 4 makes 32. Okay, so now we have y minus 6 squared. How do you think you can get rid of that squared part? Julie, you want to take a guess?
Distributed.
Instead of, we could distribute, but we're going to even be easier than that, simpler than that. Because that makes the problem bigger. And our goal is to reduce the problem and make it smaller. Melanie. So we could FOIL, but again, that's going to expand our problem and we want to shrink it down. Odette. We could take the square root of both sides. So no, you're not wrong. And Julia, you're not wrong either. But we don't want to expand, we want to try and condense. So instead of expanding it and making 3 terms, our goal is to condense it. So when you have a squared term, and that's by itself, the next step would be to take the square root of both sides. Because something that's squared, if you take the square root of it, you're doing the opposite of that problem. So the square root of y minus 6 squared, the 2, that's the exponent, and the square root cancel each other out. It's like multiplication versus division. They cancel each other out. The same thing with a square and a square root. So what we have left is just y minus 6. On the other side, we have the square root of 32. But here's where it's a little different. Because now we're solving for a parabola. Remember, anything that's squared is really a parabola. A parabola has 2 sides. It has a number on the left of the axis of symmetry, over here. It has a number on the right of the axis of symmetry. And to find those 2 numbers, we need to put a plus or a minus in front of the square root. And that then accounts for the same distance on the left of the axis of symmetry, the same distance on the right of the axis of symmetry. Because 3 times 3, not 33, equals 9, but negative 3 times negative 3 also equals 9. So we would say plus or minus 3 squared could be equal to 9, because both of those numbers work. That accounts for the negative side of a parabola and a positive side of a parabola. Or 2 times 2 is 4, but negative 2 times negative 2 is also 4. So that's how that plus or minus gets inserted into the problem, so that we're really thinking about a parabola and what a graph looks like, and it has a left and a right side. So we have to do one more thing here to get the y by itself. We have to take this 6 to the other side by adding it, because right now it's being subtracted. So we're going to take 6, add it to the other side. And then we're going to try and write this answer. We're going to put the 6 in front because it's the whole number. It really is more important. And then we have our plus or minus sign. That plus or minus is there because a positive square root of 32 times a positive square root of 32, or a negative square root of 32 times a negative square root of 32 give us the same answer. And then we're going to write the 32 behind it. So we have 6 plus or minus the square root of 32. Now, can the square root of 32 be simplified? Can that number be broken down? So look at your perfect squares. Is there a number that goes into 32? So how does 32 break down, Addie?
16.
16 and
2.
2. So the square root of 16 becomes
4.
4, and then we have the square root of 2. Here's the tricky part that's going to be different for you to think about. this 6 is a different number than the 4. Why are they different numbers? What does the 4 have or doesn't have that the 6 does have? Or what does the 6 have that the 4 doesn't have? So the 4 has a square root of 2. This 6 has nothing with it. So they're not like terms. They're not the same type of number. So I can't say this is going to be 10 because the 4 has a square root of 2 attached to it. The 6 does not. So this is your simplified solution, 6 plus or minus, and then 4 square roots of 2. I know that looks weird, but that really is the simplified answer. That's the exact answer. Questions? So why don't you look right next door, see if you can solve the next problem. They look similar. So Holly, what would we do to get rid of the negative 1/5? Multiply it by negative 5. What is negative 5 times negative 5 on the other side, Holly? 25. Okay, so we have the x squared part by itself. That quantity is by itself. Now we're going to take the square root of both sides. Because in doing that, we lose the square and the square root. They eliminate each other, and we're left with x minus 4. Holly, can you do anything with the square root of 25? What does it become? It becomes 5. But here's the little trick part that we have to now start thinking about and remembering. 5 times 5 makes 25, but negative 5 times negative 5 also makes 25. So that's that plus or minus part. I have a positive 5 times a positive 5, a negative 5 times a negative 5. And then to get x by itself, we will add 4 to the other side. So we have 4 plus or minus 5. Can those two numbers be combined together? Are they both the same type of numbers? Yes, both of these are now whole numbers. Over here, that one had a radical, but both of these are whole number values. So this really says that we have 4 plus 5, and we also have 4 minus 5. When we're factoring, we always had two x values because there were two parentheses, so there were two answers. So we're still having two answers here, it's just the answers are found differently. One answer is a 9, the other answer is a negative 1. That's what that plus or minus means. So I have one answer on one side of the axis of symmetry to be 9, the other answer on the other side to be a negative 1. Questions? So we're going to see if we can look at the one little word problem. Is there a word problem, or do you have other problems? What do you have underneath? You have other problems. Let's just do these other problems then. I thought there was a word problem. That might be on the other page. It is. So we have 3, and then x plus 2 squared equals 27. 3x minus 2 squared equals 40. So let's see if we can do letter C here. Gavin, what is the square root of 9? And besides a positive 3, it could also be a negative 3. So you should have negative 2 because we have to subtract the 2 to the other side, and then plus or minus 3. So Gavin, negative 2 plus 3 makes, and negative 2 minus 3 makes -5. So on this sheet that I passed out to you, please make sure that you're writing at the top. You're not doing all of it unless you'd like to do all 36 problems. But instead, I'd like you to complete 1 through 9 at the top. 16 through 24, so that middle group of problems on the bottom, 16 through 24. And then on the back is the 28 through 36 even, so just a couple of even problems on the back. There is a formula for you to use for some of those problems on the back, so make sure you use that formula that's given to you in the directions. So if you look at 23, I'd like somebody to do 23, somebody to do 36. Matt, you'll do 23? Okay, so Matt's gonna do 23. How about 36?